Hello guys, what's up? I'm Engineer AK, and in today's lecture we are going to solve the first sample problem of chapter 2, force systems. So let's start. So in question they say that the forces F1, F2 and F3, as they are mentioned here, F1 here, F2 here and F3 this one, all of which act on a point A, right? They are acting on this point A. You can see here. Mean they are concurrent and coplanar forces. They are concurrent because they are meeting at same point, and they are coplanar because these all forces are in XY plane. Are specified in three different ways, right? They are in three different direction. You can see this is making 35 degree with the positive x-axis. This is also making some angle, and this third force also is at certain angle. So determine the xy scalar component of each of the three forces. So what we have to do, that we have to find the x and the y scalar component of these forces, right? Like we have to find the x and y component actually of these forces. So let's start. So if I let me take this first force, right? This F1. Let's suppose we are going to solve this one. So it will be having two component. One will be like that, and if I draw the second component, so it will be like that, right? And in previous lecture, as I told you, that the axis, like this angle is with this axis, right? With the x-axis. So I will take this as a x component, this force, and this will be my y component, right? Because this is in y direction. So what we have to do, that we will just this, right? This is the x component, so we will put here the x, like I have mentioned here for the force F1, right? So what we have to do, that we know that the magnitude of this force, 35 angle and 600 Newton, right? The magnitude is 600 Newton. So 600 Newton, and this is cos of 35, right? Like that. Hold on. Okay, I can write it like this, cos of 35. And if I want to find this component, right, so this will be sine of 35. So let's put it also here. Let me copy it and let me paste it here, right? And this will be sine component, right? And here I have mentioned here that this will be the y component, f1 of x component, f1 of x, and this will be fy of x. So if we calculate it, so it will comes out to be if I want to calculate it, let me okay, so let's plug in the value. So 600 cos of 35, here we go. So it comes out to be 491 Newton, right? 491 Newton. Oops, this one. Okay, 491 Newton. And if I want to find the cos component, so it will be, just replace it here with sine. so 344 Newton, right? So it's if I simply paste it here, so it comes out to be, as we can see that, let me show you again, it comes out to be 344 Newton, 344 Newton, right? So this is the x, hold on, so this is the x, right, for, and this is the y component, or you can say that x and y scalar component of the force 1, right? Now if I move toward the force, second force, right, so you know that first what we have to do, that we will find this angle, right? But before that, let me draw the components. Different color, okay, this will be okay. So it will also be having two components, right? So one will be in this direction, and if I draw the second component, so it will be something like that, right? Okay, so you can see that it has also two components, and if I draw it here, let me draw it here a bit clear, so you will easily understand it. If I draw here, the components were something like that. Here was let me, something like that, you can see that here, right? And okay, so, and this was, I think, 500, right? 500 Newton. This was 500 Newton, and you can see that one thing more I want to mention it, that this is the positive x-axis, right? And this is our negative x-axis. So we can see that this component, if you find this component, so this will be negative because it is in negative x-axis direction. This will be positive because it is in the positive y-axis, positive axis, right? So we will put here a minus sign because it is moving toward left side, toward the negative x-axis. And here through this triangle we can easily find the angle, like if I look, it is a base and it is the perpendicular. So if I find this angle, if I find this angle, so this angle and this angle are same. So let me plug in the value in calculator. So if I find, it will be 10, let me, so here let me draw that small triangle as well. Okay, so that was something like this and this, right? And here it was 3, and this was, I think, 4. Oops. Right, so now if I find this angle, so these two angles are same. So if I apply here a tangent formula, right, so tangent theta is equal to perpendicular by base. So here the perpendicular is 3 and the base is 4, so 3 by 4. So let's plug in these value, and yeah, if I bring this 10 to this side, so it become 10 inverse 3 by 4. So 10 inverse 3 by 4, so we get 36 0.86, 36.86, 6.86 degree, right? So this will be the cos component, right, because it is making angle with this positive negative axis, right? I told you that this is moving toward this direction, and this is our negative x-axis, right? And at this side it is positive x-axis, so this component will be negative, right? So I will plug here, instead of that I will plug 500 cos of theta. So 500 cos of 36.86, and let's see what it will yield, right? So if I plug in the value, so 500 cos of 36.86, so this comes out to be 400 Newton, right? But minus 400 because it is in negative direction, so minus 400 Newton, right? And if I apply this here, it's not will be this. If I apply sine 36.86, right? So what will be sine? Let me just replace here sine. So 299.9, and if I round off it, so it will become 300 Newton, right? But positive because it is in positive direction up, and below it is negative y-axis, above it is positive y-axis, right? This is the positive y-axis, and below it will be the negative y-axis, and this is moving like this, so it is positive. So I will plug here 300 Newton, right? Here 300 Newton, right? Okay, so finally we have find the second, the x and the y scalar components, right? Now moving toward the third force, let me write here the third force. Okay, so let's first understand here. Okay, so what we are going to do that in this diagram, this is the component, so I will divide this is also into two components. So first component will be like this, right? And if I draw the second component, so it will be something like this, right? So here we get the two component, and we will now find this angle, and this I can call it alpha, let's suppose, right? So now from here to here, what will be the distance? So from here till here, it's 0.1, right? And then from here till here it is 0.3. so from this point, from point A till here, it is 0.1 plus 0.3, right? So it becomes 0.4. I can write it here, it will be 0.4. And if I want to find this, so you can see that from here till here it is 0.2, right? And total is 0.4. so from here till here it's 0.2. so if this will be 0.2, right? And this will also be 0.2. so combined, if I plus the both of these, so it will give me 0.4, right? So now we will solve this triangle, right? So let's now move back. So here I have already drawn that force, right? That from here till here, it's from point A till here it was 0.1, and then from that till below it was 0.3. So if I sum these both, so it will combine and give me 0.4, right? And this was 0.2, right? Because from this point till this it was 0.2, as I told you up in the diagram. You can see that here, right? And from here till here it's 0.2. So I have mentioned it. So now we will solve this triangle. So it will be, so this is the perpendicular, right? And this is the base, right? So the base is 0.4. so if I here apply the tan formula, so tan alpha is equal to perpendicular by base, and perpendicular is this was the perpendicular, so it was total 0.4, right? It was total 0.4, and if I minus 0.2, so that will be the perpendicular, and the base was 0.1 plus 0.3, right? So let now, and if I move 10 here, so it will become negative. So now let's plug in the value in calculator. So tan inverse 0.2 divided by 0.4. So oops, tan inverse 0.2 divided by 0.4. so it is giving me 26.5 degree, right? Or I can say that 26.6 degree, 26.6 degree, right? So I will plug it here. So this will be the cos component, again this will be the cos component now, right? And this will be the sine component. So cos component and angle is, let me directly plug here. Let me plug here, and let me plug here, right? So now if I plug in this value in calculator, so 800 cos of 26.6, so it is giving me, so we can see that it comes out to be 715.32, but it is downward. So, and we know that downward it is in the negative y-axis, right? So I will write here minus sign because it is negative y direction, so 715 Newton, right? And if I want to find this x component, so I will just plug in here sine 800 sine of 26.6 degree, so it comes out to be 358 Newton, right? 358 Newton, right? So finally we have find the scalar component of this as well. Now if I want, if let's check directly this through calculator, so you will see that whether our answer are correct or not. So let's suppose for this component, what we have to do, that mode and then complex mode, right? Complex mode is on. Now plug here the magnitude and then angle, shift and then this angle button, right? And then angle 26.6. so here we can see that the cause was 715, right? And the second one was 358. Here we can see 358. Now if I want to find the second and the third component, so the magnitude was for the fourth one, right? Magnitude was 600, and then shift angle, and the angle was 35 degree. So 491, here you can see the x component was 491, and the second was 344. So you can see the second is 344 Newton. So the first force is also correct. Now for the second one, again the magnitude is 500, then shift, angle, and the angle was 36.86 that we have find 36.86. So the first component, x component, was 400, so you can see here it is also 400 Newton, and the second component was 299.9, or if you round off it, so it become 300 Newton, so it is 300 Newton. So we can see that our answer are correct, and we have verified directly through calculator. That how you can verify it, right? So that's it for today, and see you in next video. Thanks for watching.